Graphics, because that's them who started the whole stuff. They were having an API for doing this. They were not doing shape. All the special effects that you had in movies were doing offline. They were rendering offline, but to visualize at least the 3D object, they were using what they call Iris GL. So you can guess from start, I won't spoil you, but you can guess from where OpenGL is coming. It was considered very easy to use. That's why a lot of people use it. Use this station graphics and this graphics station and server, because it was very easy to use. It was mainly C. This will have an importance for the rest. So let's consider like that. Before this time, SGI, nobody else doing integrated graphics and rendering graphics better than them. They have their own API, their own hardware, own API, and they are very successful. But then other companies come. And then these companies are less expensive than SGI. And they start to have some competition, let's say. SGI start to slow down a little bit on their selling. Even if IrisGL is still at this time considered as the best API. They see that. So what they are doing? One solution is, so we are switching another time. We are now in Nocrusius Doxan Iki. SGI is losing some competition. What they are doing, they are opening IrisGL. And then IrisGL is equal OpenGL. They are not opening it completely, in fact. They are just opening the specification. It's not like open source software, just the specification. And they are making them more generic. That means anybody is free to implement something that is compatible with the OpenGL specification. For that, they are creating what they call AREV, which is the, not to make any mistake, Architecture Review Board. That is basically a bunch of people will be agreed all together about what will be the evolution of OpenGL. So it's not only anymore SGI who is deciding about the future of its own API, but they are opening it, they will be part of the board, and now it's a consortium of companies that will be agreed together to make evolution of OpenGL, evolution of the specification of the API. OpenGL is defined from the beginning like that. That is what they call a core plus extension. Two parts of OpenGL. To be conformant to OpenGL, any version, you have to support the core specification of OpenGL. That means you have to support everything that is written and should behave like it is written in the specification. Otherwise, you are not compliant to any version of OpenGL. You can download the PDF of this core specification in OpenGL, in Crémoux website, because now it's Crémoux, I will come to this point, but the official OpenGL website. And if your graphic card, if any hardware, if any software you are using is supporting a version of OpenGL, then it should behave like the core. You will see that it's not always the case, but it should be like that. Plus some extensions. What are extensions? Extensions are functionality that some members of the ARIB want to support, but not that included, let's say, the official version of OpenGL. That brings a lot of problems, in fact. Because not all the hardware manufacturer will support it or not, or this kind of things. But let's say, as long as you target the core, if you take any graphic cards, let's say for 2 days, if you take any graphic card that you support the version, you are expected the core to work and to behave normally. The point is, you are not sure that it will be done in hardware. It is supported, but it may be implemented in software. That means you can have a very nice function that will work on a specific hardware fast, and you will switch to another hardware, and this function will be supported, and it will have to be in the BA, but maybe you won't have the same performance. That's also another good point, important point. Okay, so OpenGL is created. By the way, it's OpenGL dir, not as a version. First version. Let's move a little bit. Now we are in Windows Sandbesh. Okay. What we are doing this year? We have Windows Sandbesh, of course. And also what we will have is DirectX. And also what the part is interesting is DirectX. Just to show you, remind you, a part up. Oh, is it a bit dark now? No. Okay, we don't see it correctly, but it is basically Quake. First version of Quake, it looks like 1995. Real-time 3D game, real-time 3D game installation done in software. No hardware supported yet, but it was done in software. The CPU was very fast for this time to support it. We were not speaking about graphic card yet, we are speaking about video cards. Okay, Windows Sandbesh comes. Microsoft introduced their DirectX. Why DirectX? Because there is a lot of things in DirectX. Basically, the X is for you to replace by component. They have direct input to support gamepad, mouse, keyboards. They have direct sound for the sound card. They have direct draw at this time. Or direct 2D, I'm not sure if it was still draw, but 2D. Basic shape. And of course, HD comes also at the same time. Where it comes from a company, Random-Morphic. The name is not very important. The fact is, Microsoft bought this company, and this company was doing graphical IP for CAD software. That's the very interesting part also. And at this time, Direct 3D was separated into two parts. There was an immediate mode, we call it immediate mode, and a retail mode. What is the difference? Immediate mode was just like OpenGL, in fact. That means we were making directly call to the API, to Direct 3D, and it was doing the job directly. Like draw me your triangles, load me these textures, make me this matrix multiplication. It was direct. Rotate mode on the other side was based on scene graph. It's very interesting because on the beginning of IrisGL, before it becomes OpenGL, there was IrisGL, but there was also scene graph application to handle your data, to be able to structure your data, to load your data into scene graph and organize your data. Not only the IrisGL displaying API, but also the organizing all your data before displaying. And Direct usually has these two modes. Immediate, you directly access, or you can build your scene graph and then after display it by very high level functions. And another difference difference with OpenGL. If you are compliant with OpenGL, you have to support at least the core. In Direct2J, it's completely different. Because in Direct2J, you query the hardware, what is capable of. If it's not supported by the hardware, then it is not there. That means if you have a very nice function, but it's not done in hardware, then Direct2J will tell you, I'm sorry, I can't do it. In OpenGL, if the manufacturer implemented it in software and not in hardware, we say, I can do it, but you are not sure about the result. That's also another big difference. OpenGL, you have to support everything. Direct2J lets you query the hardware to see what it is possible to do. But then you have to design your software accordingly, and you have to, before you start your software, you have to query the hardware, and depending on what you can do, maybe you need some path of rendering in your application. So that makes maybe two different philosophies. And starting from that, the support of OpenGL in Windows Docs and Dash will stop at OpenGL behavior package. From this time, Microsoft will never improve the integration of OpenGL with Windows. Because OpenGL cannot do things alone. You need to access the Windows management in the operating system. And then use OpenGL through the Windows management system. So a link needs to be done. And Microsoft will stop this link between Windows and OpenGL. I mean, we stop at the version V.NET. That brings a lot of problem effect when you want to implement OpenGL in Windows now. Because you don't have access to the new, you need to do some tricks to be able to have access to the new version of OpenGL that your hardware is capable of. But of course, you can understand it because they were introducing their new APIs, so they just stopped to work there. Start to implement and support OpenGL. Okay, let's move on a little bit. Continue. Now, fini Doxan Locus. Year of matrix. Just checking time. What will come? Quake 3. OpenGL. Full support of OpenGL. Multi-discipline. It was a game basically that brings support to OpenGL. Because most of the games before that, when the 3D stuff comes, were mainly create 3D. During this time, what we will have? We have Direct 3D improve a lot during all of this time. We have Direct 3D 7. They were very, very fast implementation. And OpenGL 1.2.1. Okay. Now, there are not anymore video cards. Video cards are admitted. NVIDIA introduced the term of GPU. That's them who invented the term, graphic processing unit. They have put a patent, by the way, over it. With the GeForce, it uses a Yelp. Maybe some people do have some. It was running quite very good. So what it is made for? What they are doing? Why graphic processing unit? Because before it was just video cards. Video cards basically are digital to analog converters. No, now they are doing what is inside the API directives, which they OpenGL in hardware. Basically, this one is doing matrix computation on hardware. You can OpenGL has matrix type, DirectX has some matrix transformation that you can call. It is passed through the GPU, and now it is done in hardware. It is done much more faster. There is texture sampling, texture coordinate, everything is done on hardware. Or let's say most of it is done on hardware. So we are going really from graphic card to GPU. Now it's becoming a real processing unit that doing 3D stuff. So we are okay. So you are something, what is the GPU? I don't know if you know the term of FPGA. It is for Field Programmable Gate Array. Basically, it's an array of logical blocks. Imagine you have something like that. You have a additional block, add block. You have a that do addition operation. You have a multiplication block with multiplication, and you have, let's say, for you to understand how rendering was going, let's say negative block that do the multiplication by minus b. You had in the GPU basic operation, and when you were doing rendering, you were just combining them. It's a very simple way. It was containing much more logical block, but let's say it's the basic idea. So imagine that you want to do a minus b. Basically, you take change this logical block. So you take b value, you pass it into a negative block to have minus b. After you pass it into a add block that you put value a, and you have your a minus b. Rendering was not like that. Combining logical blocks with texture, with data that are some textures or some vertices and some 3D models, and you were arranging your logical block to produce a rendering, mixing them, multiplying them, making operation. So GPU was that. Just a collection of basic operation, and you have to combine. But of course you are limited, you don't have unlimited logical operation you can have. At this time, mostly you can make, as far as I remember, project you can make 16 operation blocks simultaneously. So you have some kind of limit. Okay, you can do some stuff, but if you have very complex operation, you want to make a pole, for example. A pole is multiplication, but you can go up to power of 16 maximum then, because you have only 16 blocks. But you need some operation for other things, or maybe you have to do it in 2 passes, 3 passes, and combine with buffers. So, still, you can do stuff, but limited. Another point, difference about also a very important point, in fact, between Direct2HJ and OpenGL is now in Direct2HJ you can have access to the memory of the hardware to put your model. I don't know if some of you already look a little bit at OpenGL, old OpenGL, but you had some things like that. You start with the GL in, it is old OpenGL. And you have GL grapics stuff and a GL plant. GL grapics you define, and after you do all your stuff. Basically, when you are doing that, and you will do that every frame, you render, and you render, and you render. What you are doing when you are doing that? You have your CPU, memory, you have your GPU, memory. When you are doing that, in your loop, you are sending your data every time. From the CPU memory to the GPU memory, every time. So it was, you were streaming from the CPU memory to GPU memory. That was OpenGL. Direct2HJ on the other side let you do something. They say, okay, you have some data. Just copy it to the GPU. And then, after you do rendering, and you will just tell the rendering, okay, please use this data. Huge difference in performance. Very, very huge. Because GPU has some memory, they can start to increase the memory of the GPU. And then it was becoming very, very fast. So that was a big, one first step, really, where you can mark that, okay, Direct2HJ is going forward in comparison of OpenGL. Just by these first steps. And moreover will come on the after. So let's move forward a little bit again. Iki bin, iki. What we have? Direkt 3'de 8. Ne? 8. And open GL divide point 4. And something. And something that will change a lot the way you deal with GPU. That is what we call shaders. And that will be the separation between directs. That will be very well direct and 3D will go really fast forward. Okay, where shader is coming from? Shader is coming from shading. Why shading? Shading is, let's say, the way you fill the triangles that you display. Yeah, you calculate the pixels. You have triangles that you display on the screen, and you have to find the value of the pixel that is composed of your triangles. This is what we call shading, because you are applying some shading on the triangles. It comes from that, because the first shade, again, NVIDIA, introduced the first shading language with the GeForce 2. They had a pixel unit which can run shaders. Okay, they are shading, but they are programs. They are not any more logical blocks that you arrange. They are full qualified programs. I mean, limited, but you can do much more than just having a set of logical blocks. You can do real operation. They have their own language for it, but all that constant pixel unit is really okay. How you feel texture and how you feel a pixel on the triangles, you can start to make effect, and you can start to mix, and you can start to do very crazy operation. That is really the big difference.
David, I couldn't understand the difference it's introduced by shaders.
Before you have logical blocks, predefined. That means you have operations that are predefined. And you have a limited amount of logical blocks that you can combine together. Typically it was 16 blocks. So that means, moreover, if you want to do some kind of operation, you have to add the block that is coming with, or you have to combine it. And you cannot do more complex operation than, let's say, 16 blocks complex operation. Let's say you want to make blend two textures for one pixel. So you have basically add block that will take one value, another value, and will output another value.
Yeah.
These blocks shape will take color and shape. We take just one texture because most of the blocks are just taking one texture and one value. Because I give you an example, this is one block that I remember, and I put you a color out of it. So basically, if you want to combine two textures, you need to have another add block to output your addition of the two textures. You cannot just make one operation. It is a two operation stuff. You have basically complex operation that this value you will put suffer because you don't want to I mean it will be black because you don't want to add any things. And then you will sample the value of the texture, you will add it suffer because the block is defined like that. You have no way out. You don't have a block that takes two textures, for example. Because they are made to, these logical blocks are made to be more flexible possible in the term of all the API design. So just to blend two colors, and no, it's not even blending, it is just an addition. You want to blend it? If you want to blend, that means basically you have your color suffered, you want to multiply by a certain factor, let's say, and you want to add your other color multiplied by 1 minus, and it will be your final color. If you want to do an operation like that, you have to first extract the color, multiply by a factor. You have to make the operation that will take you inverse, which is opposite 1 minus the factor in another block that will combine it, multiply by a texture that will come after, and have the final color. You have to use all these logical blocks. So that, and don't forget, you are limited in the number of logical blocks you can have. So you cannot do exactly what you want. This presents you a set of operations, and you have to think, okay, how will simulate my complex pixel modeling using these blocks. And its shaders, you don't have to care about anymore. You write it directly. You write this operation directly into the program, and it will be evaluated. It's more like a program. It's like, how can I find an analogy? And moreover, these operations are not as simple as that, because they keep on adding new logical blocks.
Why did they wait this much long? Due to hardware performance problems?
Because most probably OpenGL was very slow on the evolution of it. There is a point here. OpenGL doesn't believe in shaders at this time. They don't believe it. They say logical blocks are enough. No problem. We just continue to add more logical block, more logical block, more logical block to make more complex operation. Will increase the number of logical blocks that you can read. They were not believing in shaders. And it can come with it because it was obvious. I mean, you are limited. Let's the developer program their own code they want to run on the GPU. OpenGL say no. The RAB say no. So what they go? They just go to Microsoft and said, okay, we have these things. And Microsoft created the first shader language with derivative sequence. It was assembly. It was very, very basic, but there was enough instruction to do more, much more than what you can do with logical blocks in OpenGL 1.4. That's the point of OpenGL. At this time, that was very, very strong, and that's where it did. Which it was very, very fast because they were the first one to support. Moreover, they support NVIDIA hardware, so NVIDIA was very happy, and it was bringing a lot of new stuff for graphical developers. Even if it was a little bit hard this time. And also, just to give some insight to it, that's also at the same time that Microsoft released its first Xbox. Xbox is coming from DirectX box. So it was really what they wanted to do is we are the best, and moreover we produce hardware to show you this is the best. The graphical processor of the it was released in here. The graphical processor of the Xbox was made by NVIDIA. Of course, they were the first one who were producing shaders, and it was equivalent to GeForce, if you just want to have some reference. With both shaders from the vertex processing and the pixel processing. That means that you can program how the vertex are transformed and how the triangles is filled. So basically what we have, a little bit of graphical cards. That's what the thing. On another side, share some reference also because at the same time Nintendo released the GameCube. The graphical processor inside was made by ATI, which will become AMD in the future, and it was supporting OpenGL 1.4. Just to give you a comparison. Okay, let's move on. Because now things will go faster. Ekibin altı. what we have in terms of video game. We have that Doom 3. PTB Dirt, if I'm not wrong. What we have in terms of API? We have DirectX, DirectX or DirectX, anyway, they are coming. 9. And also we come with the C. There is a C version that will come after. And OpenGL 2, but there is a trick. It will only come in 2004. Okay, what they do with DirectX UG Docus? Shadow language, better shadow language, HLSL, which is basically close to C. It is some kind of equivalent of C. Very nice. We go from assembly to now you can program your own code on the GPU in C. Developers are really happy. Floating point texture are coming also, which could be nice if you want to do things like high dynamic range rendering. Multiple render target, I mean a lot of features. DirectX 9 comes with a lot of feature, very close to the hardware. And OpenGL, with OpenGL 2 in, 2 years after, come with their own, with their shadow language also, GLSL. Okay, one big difference between the two. Microsoft, always very friendly to the hardware sellers, is providing a compiler. He's saying, okay, this is my shadow language, it's very nice, it's close to C. I know that you hardware seller, you cannot support it, so I will provide you a compiler. So you have a compiler for this language to, let's say, something very close to assembly, very close to the hardware. We can call it EL for intermediate languages. It's assembly, let's say. So it's very nice. On the other side, OpenGL say, okay, we have a very high level shadow language, also like the 3D. But the hardware manufacturer has to provide a compiler. So, developer has nothing to do, but you pass directly the code, the C code. This is also important to see, but the graphic card has to, the hardware seller has to provide a driver to compile the shadow language. And that makes also a big difference in terms of support. Because drivers are not exactly efficient, and sometimes you have bugs, and sometimes you don't have the extension that goes with it, and it works and it doesn't work. Big problem. You have a lot of revision of the shadow language. Come with a lot of revision. That's definitely not really. But yet, Doom 3 is OpenGL. But they are using very little shadow language on it. Another important date is, I don't know if it is really important, but in 2003, Microsoft left ADeko. Like I told you, ADeko is the consortium that decides in which direction OpenGL is going. It's made of a lot of companies. But this year, Microsoft left it. There is not really a reason behind it. Most probably they just wanted to push what they were doing and their API and this kind of thing, but just as a fact, just like that, just informative. Something happened, interesting also around OpenGL. Okay, definitely OpenGL is behind the 3D. 3D Labs. It is important because it's them also who proposed the shadow language. They try to push OpenGL. They see that OpenGL is not moving and still in the past, let's say, not going forward with the hardware. They try to push, they try to put a lot of proposals to evolve OpenGL. Most of them were rejected. Just the shadow language remained, but all the other proposals that they give to the ADeko, most of them will say no, and that for me will put you will see after, but that not accepting this because they were. You can see, okay, let's say GLSL was not very suitable for hardware seller, but it was a very big step in terms of what will become the future of the shader, because now the shader are very close of what GLSL was proposing. Even if this version of the high-level shaders were nice, DirectX 9, this one was very much more close to a real program, real computer program, things that you can code. So they had vision. They have really a good vision of what will become the future of the GPU. And MANEZF, the RLA, the consortium of OpenGL, just keep the shader language and reject all the proposals. That makes it very, very awkward because you have something very high level mixed with a bunch of old-fashioned, let's say, function API. And a lot of people don't hear about that also. I mean, this kind of modern stuff, but hard to support with old style API. Just as an information also, in keeping Vesh release of Xbox 360 with the custom version of DirectX 9, which will become basically DirectX 9 plus some functionality that will become DirectX 10. And interestingly, the GPU is made by ATI, not NVIDIA anymore. IT, okay, I didn't explain it, but they had some late advancement. NVIDIA was the first one, really the first one in the previous year, but ATI bought a company. And this company brings a lot in terms of improvement of the shader and improvement of GPU. So they go, during these times, the best graphic card were ATI. That's why most probably Microsoft goes for that, and they were supporting really, really fully and in better quality in DirectX 9. To give you an example, in the shader language you can specify the precision of the floats. It could be the float, and DirectX 9 doesn't give you any recommendation, just you know, DirectX you have to query, you have to ask what you can support and this kind of things. You can have 8 bits, 16 bits, 24 bits, or to the key bits of support of the floats. Basically, NVIDIA, as far as I know, if I'm not wrong, maybe they were, pardon, they were supporting 24 bits of floats. That was NVIDIA at this time. And ATI was supporting the full set. It was the starting of, they were trying to, for example, academicians, people who were making research rendering were starting to get interested in graphic cards. Before they were doing all their rendering into CPU, they were saying a graphic card. We are doing very complex rendering, we are doing very complex computation, so graphic card was suitable. You can do computation on floats of 32 bits? That starts to be interesting. And they start to do some rendering techniques. There's a famous ATI demo, environment mapping in high dynamic range from Paul Delec. Basically, which was first a paper that how to render high dynamic range with real lighting done in CPU and transfer it on hardware. It was not demo because ATI was supporting 32 bits of floats, and it was a huge thing because it was in interactive time. Before it was rendered, now it is interactive time. That's where ATI goes a little bit forward in NVIDIA for this time, because ATI was a little bit forward, just because of that. And you have other complex things, but basically because of that. Okay, let's continue to move.
What was Apple doing in the meantime?
They are supporting OpenGL, but they are always supporting old version of OpenGL. Don't ask me. A little bit forward, back, they are supporting also. They provide a lot of extension to OpenGL.
They don't have their own API.
They provide a lot of extension to OpenGL. 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 They p No. They use OpenGL, but they always adapted their source. If I can say like that, it's correct to say like that. You know, okay, we support OpenGL, but we want to do also other stuff for ourselves. But they are always a little bit backwards in terms of evolution of OpenGL. They have graphic cards that support higher version of OpenGL, but officially in their operating system, that just so you have to query, in fact, the extension. You remember the core plus extension. In fact, before something goes into core, it's first an extension, and then on the next version of OpenGL, if it is meaningful, the extension passes into the core and become the new version of OpenGL that you should support. So basically, they were having ATI, NVIDIA cards, some Mac and MacBook and this kind of thing. The system was telling you, for example, okay, it is OpenGL 1.4, so basically no shader. The system was telling you that. But if you just query the extension, you realize that as you have ATI card or NVIDIA card, yeah, you can do shaders. But you go to the extension. Basically, they are the same function, but you have to query.
I see.
Officially, they were putting a very low limit, and still they are putting a very low limit in macOS. I guess they are not supporting more than OpenGL 2 something. Officially. That doesn't mean they can do more, but they are still in this exposed. I don't know. That's the interesting stuff. To give you another thing also, that's what we could do also in Killing the also. Far Cry. DirectX 9. So on one side you have OpenGL, and on the other side you have the two games were fighting for both FPS some sort of. Killing 8. So Direct, HD, 10, and Windows Vista, where everything got broken. I'm speaking for Windows. Okay. Microsoft with Windows Vista introduced a new display driver. They know that the old system, Windows XP, was not Windows and was old stuff, so they provide a new display system. New display drivers, new thermal validation, more integrated with the operating system and the graphic cards. IRO, what they call IRO, is done on the GPU. Should be. Okay, there is bugs, but should be done on the GPU. So what they will bring with it? They bring a new version of Direct 3D. 10. What they give in Direct 3D 10? More unified shader. Before, you know, the rendering, not going into details, but let's say you want to render some triangles, you have to go to a series of process before you go to the screen from the data. From the data to the screen. You have to go, I'm not explaining all the things, but basically you have to this step, then this step, then this step. That is, you cannot go escape that. This is how the GPU works, it is even with shaders. And at some point, you can inject some shaders to define, okay, this step will be controlled by, not by parameters, but I will provide my own code for you to do that. In DirectX 9, each shader or each step that you can customize has some kind of its own specification, its own language. What DirectX 10, Direct 3D 10 brings, now they are the same. Shaders become more generic. And moreover, they add you more control to different steps of the rendering. More generic, just think like that. It becomes more generic. The shader code is almost the same at different stage. You write it the same way. You don't have to think about, okay, I'm going to put a small program for this step, specific step of the rendering, which kind of function I can use. Now they can use all the same functions. They introduce also something else. They are doing now like OpenGL. You know, before DirectX 3D, you have to query the hardware. Can you do that? Can you do that? Now they provide a minimum support. That means your graphic cards should do a minimum set of functions if you want to be qualified as a Direct 3D 10 graphic cards. That changes also a lot of things. And I'm telling you now you can put also they introduce geometry shader. Okay. What is important about that? In the processing of rendering, the geometry shader allows you to create new geometry on the fly. That means you will render triangles, and when you will go to the geometry shader, that means it will be done on the graphic card, it's not done by the CPU, it's not done in memory. You may end up with, I don't know, shape. Maybe more triangles to render to the graphic cards. Or even something different, if you want to do some different stuff. You create directly 3D data directly on the GPU. That's also a huge step about a lot of effects, a lot of effects. And that comes with directic step, directic 3D then. On OpenGL side, what happened? Nothing. They are still in their old version, providing some extension, but basically the version of OpenGL is not moving. And people are waiting. People are waiting for the new version of OpenGL. On the other side, on Microsoft side, you have DirectX 10, which is improving and bring new stuff, supporting more hardware, supporting more stuff. And OpenGL, what you have nothing. No, Steve, one thing happened. Now, you don't call them anymore ADeko, call them Crémoux. So if you go to, now if you want to have access to all OpenGL and all rated stuff about OpenGL and other open stuff API, you go to Crémoux, not all, and you will have access to all their stuff. This is their new official name. Just as also, during this time, the PlayStation 3 was released. And interestingly, it was some kind of based on OpenGL, but with a lot of extension. It was not real OpenGL, it was their OpenGL, not official OpenGL. Okay, let's move on. Now, we are going to the 2008. I don't know what kind of games we had during this time. We had Crysis. Okay, what we have? On Microsoft side, they continue their job. Direct 3D, 11. Preview, just a preview part. It's not official, it's just a preview, but they are already saying what they will put inside. This is a huge year for OpenGL, because OpenGL goes to version 3. Okay, now, what is OpenGL 3? A lot of people are waiting for it. They make a lot of promises. They say, we hear you, we know that developing with OpenGL is not nice, it is still old stuff. We'll change everything. We'll make everything to please you. We will delete all the old stuff and we'll put only new stuff that will match the hardware and this kind of things. Everybody was very happy. And then suddenly, blackout. No information anymore. What is the new version of OpenGL 3? The code of OpenGL 3 was long pick. If you just search on internet for long pick controversy or long pick criticizing, you will find a lot of articles. They just come blackout, really blackout. No information coming from Crémoux, because now it's called Crémoux. People waiting, what they are doing, what did they do? And then suddenly, they come with the OpenGL 3 specification. And it was a disappointment. In fact, they didn't do what they said. They introduced some kind of forward, backward compatibility that you can create OpenGL 3 in forward. That means you are some sort of moving the old function, but they are still here, you know, it's not completely removed, but if you try to use them, you will have error message. They just keep the same thing and just put new stuff inside, but I mean, it was still the old way. A lot of developers were pointed. Even some of them, some big companies threatened to say, okay, game companies, we should, okay, we'll switch to DirectX. Yeah, I mean, there is no point of going to OpenGL anymore. Even during this time, and also it was before Carmack was a very big support of OpenGL, said DirectX in fact is nice, and why should continue to support OpenGL? They are not moving forward. So that was a big disappointment. And moreover, the interesting thing is OpenGL 3, to support OpenGL 3, you need to have at least direct UHD graphic card capable, capable, but without the geometry shader. You know, the new feature I just introduced you. That means basically you need to support to have the same equivalent graphic card that will do the things. But on OpenGL 3, you cannot use the hardware feature that was introduced, the new hardware feature that was introduced in the 3D10. So people are getting very angry about that. You need more and you can do less. That's the point. Let's move forward. In 2009, just 1 year after. Okay, now you have Directory 11. You have Directory 11, you have Windows 11. Here comes the rest. Everybody is happy about that. And OpenGL 3.2. Okay, they made some improvements. To be serious, they made some improvements. But they put geometry shader. At least. And everybody was waiting for it. Anyway, they have to put it at some point. DirectX 11, you have some new algorithm, like tessellation algorithm. That means with some very low polygons mesh, you can make something smoother. New stuff, I mean, just new stuff. Based basically on the geometry shader. Interesting point. GPU are becoming more and more generic. Less rendering, but more like a good processor that can do floating point operation. So what they bring with Direct 3D11 is direct compute. What is direct compute? Direct compute is basically, okay, if you don't want to do any graphical stuff, no problem. You can still use the graphic card to do very complex computation. You have a floating point hardware which is very strong and very faster than your CPU. Just code using same language and you can do computation. Basically, it makes a link between the CPU and GPU to make generic computing using the GPU. Not in rendering part, but just as a generic huge stuff. A lot of people starting to use it. To give you examples, a lot of ray tracers start to use this kind of things, for example.
Sorry?
But a lot of ray tracers start to support this kind of
finite element analysis.
For example, I mean, it was used for academic. Now you have access. You don't need to do to go into direct 3D or OpenGL. We just give you an interface for you to use the power of your GPU to do anything you want. Give you an example. Bitcoin was coming. They were doing hashing or using the GPU because the GPU was very fast doing that. Nothing related to graphical. Just use the GPU because it's fast, it's powerful to do operation, computation, mathematical computation. Huge efforts, another huge efforts. Okay, let's continue to move on. For the moment, you realize that OpenGL has moved so much also. 2010, 12. Rage, if you hear of it. Made by id Software, still in OpenGL, but using a lot of extension. To give you some things about the OpenGL problems, there is some kind of a controversy about it. The game was previewed by people as they were using extension, because you know OpenGL is the corpus extension, to access to the last hardware feature of the graphic cards. Basically, they have two versions of the rendering, one for NVIDIA, one for AT, which was not updated still, I guess, or they were doing whatever. To support through graphic card through extension. At the release of the game, when the game was released, everything was perfect, everything was nice. At the release of the game, AT made a release of drivers at the same time that breaks completely the game. And not on NVIDIA. So that was also the prime of OpenGL at this point, because you were creating extension and then the extension was not working as expected, or there was some bugs and this kind of things. Interesting stuff. OpenGL released version 3.3 and 4 at the same time. Two versions at the same time. Why? Because just to finish the work that they couldn't finish for DirectX 10 equivalent graphic cards, and to say, okay, we are still in the course, please wait, but we are here. So there is 4 just to compete with the DirectX 11. And at the same time also, there is OpenCL 1.1. 1.1, which is basically the answer to direct compute. The same, provide the same service. I mean, use your graphic card to do basic operation on your computer. Not for rendering, but for the daily computing. Okay, at this point, we are still in DirectX 3D. It's evolved a little bit. We are doing 3D 11, not that big. And also, Windows 6 is coming. DirectX didn't involve a lot. Just add additional functionality, but basically. Starting from now, OpenGL will be just trying to catch back all the road they lost from Microsoft on Direct 3D. So all the version that will come from that, we just show you, okay, we know that it exists in DirectX 3D 11, okay, we are putting it. And they will increase their version, just adding new stuff, adding new stuff, adding new stuff. But still the big problem of OpenGL is they are still keeping their old-fashioned API from the beginning. I mean, the way they try to, it's like you try to force new functionality in an API that has not been designed for modern hardware. So they try to mix with old function, with new function, with new parameters and this kind of thing. 3.3 was meaning still something, but after 4, my opinion, personal opinion, it started to become a mess. A big document, specification, core specification, big PDF, very hard to understand because the old is meeting the new, and it's very hard to understand, very hard to make something out of it. Okay, so that was basically the state of this, what we were for a few years. Not moving so much, DirectX 3D 11. Everybody was, Microsoft was happy with it. Not so much news about the DirectX 12. OpenGL was catching back on DirectX 11, trying to add new version, I mean 4.1, 4.2, 4.3, 4.4, etc., etc. But we were reaching some kind of plateau of graphical improvement and graphical quality. This was in 2011. Now, this is what we have in Battlefield 3. In 2013. Why Battlefield? There is a reason for that. And just to give you an example, in 2013, Microsoft released Xbox One and Sony released PlayStation 4. The funny part of it, they are based altogether on AMD, which is the old APU. APU is some kind of combination of CPU and GPU on the same motherboard, let's say. Same hardware. DirectX 11, DirectX 11 compatible. OpenGL for something for PlayStation 4, but basically same hardware. same hardware, just frequency difference, memory difference. That's why most of people say PlayStation 4 is better than, but it's just a frequency. Basically, the architecture is exactly the same. It's a X pardon, 8-core CPU with some graphical part. Okay. Yeah. So, how is the market during this time? NVIDIA is still considered like the best one in terms of performance, in terms of hardware, price, compatibility. They are same. Still, AMD is earning some money. They are producing a processor for the big video game console. Let's say. Microsoft is happy with DirectX 11. You know 11, not that gear, no big major evolution. Bungie is getting back on open, they have already a lot of work to get back from DirectX 11. Okay, but we come as a plateau, as I told you. Why? Because of the drivers. We are speaking in a machine that have two processors, two memory. There is synchronization problem. There is memory that you can check. You cannot do the same operation here when you are doing the same operation here. They are running at different speed. You have to be sure that one is finished before the others. All this stuff, all this multi-processor, different frequency chain, that is done by the drivers. The drivers is here for you to forget that you have a completely different hardware beside your CPU and your memory that you already programmed. They do all the job for you. They check, they recheck, they recheck. They are sure that safety is done for the memory, not to crash. Because if you are running a game, I mean, okay, crash can happen, but I mean, just to be sure that GPU won't crash, because if GPU crash, everything crashes. But because of that, there is a lot. We come to a point, in fact, that most of the application has CPU bonds. What does it mean, CPU bonds? That means the CPU is working more than the GPU. Whatever optimization you do, whatever you try to do fast, because this layer, driver layer problem, makes you not to have fully access and fully, you cannot exploit maximum the power of the GPU. The GPU is growing fast. More instruction, more memory, 1 GB, 2 GB, 3 GB of memory in GPU. But there is still this problem because this is your only way to speak to the GPU. And these things is checking everything. We check, a lot of time. So, what happened? In 2013, a company, DICE, who is making Battlefield, go to AMD and told to them, okay, that's nice, but please, can you just remove that part? Or at least make it smaller. Let us, I mean, it's a long time that we are developing with multi-core CPU and accessing memory. We know how to do that, how to handle concurrent access to memory and this kind of thing. Just make a thinner layer and let us access the GPU, the memory. Let us access directly to the things and let us do the job that the driver is doing. Okay, we'll be careful. And they said, yes, come on, let's try to do something. And they started the project Mantle. In fact, it was a good choice for me because AMD was behind NVIDIA for the month. NVIDIA was better selling and more sharing. Now, the market, they were just having, how can I say, more I mean, when you are shooting, and even for ADeko, when you are shooting graphical, you are saying, take NVIDIA because they are supporting all the thing. So, that's when AMD Mantle came. Mantle was an alternative set of drivers for you to directly access to GPU. And then the thing started. What brings Mantles? Mantles is oriented multi-threading, which was not the case. DirectX 11 introduced some multi-threading stuff, but it was not perfect. OpenGL was definitely not multi-threaded. And we were working in multi-threaded environment. Why not to make drivers multi-threaded? It makes no sense. So the first thing is multi-threading. DMA, directly memory access of the GPU. You don't ask the driver to create you something for you and access it through a set of functions. You create it to a pointer. But you have to be careful about it. But you can have access. And moreover, you have the direct access to all the capabilities of the hardware. Direct access to the hardware. That means you have access, you don't go, how I can explain is that it's like, if a graphic card is proposing you a new algorithm or a new way to do things, you don't have to go through all the way of doing it through the API because the API is not updated to match it to thing. You have directly access to this function. And you, of course, you have to adapt your code to access to take profit of this function, but now you can directly query it and not have the bunch of all the old functions just to do the same thing. So, DICE released some kind of benchmark out of it. Huge performance, 20%, 30% better, even 40% on some cases. Then, very interesting, I don't know, actually, it's just an outside point of view. I don't know what really happened in the companies, but then it was a panic. I feel it like a little bit, it was a panic. Panic, what?
Panic for who?
Okay. 2013, DICE announced Mantle with AMD. In 2014, Apple announced Metal for iOS. What is Metal? The same. It is a driver. Forget about OpenGL. You give you directly access to the hardware of an iOS platform, and you have directly access to it. But of course, their own way, because Apple is always doing their own way. Ah, it was in July. September 2014, Microsoft announced DirectX 12 or Direct 3D 12. What is the new feature of DirectX 12? Direct 3D 12. Direct access to the hardware. No layer anymore. You can do everything you want directly to the hardware. No more old-fashioned API and this kind of thing. Same. March 2015, Crémoux, the guy from OpenGL, announced Vulkan. What is Vulkan? Direct access to the hardware without the crap of all the driver that all the API that OpenGL brings. That's why I call it panic. I mean, starting from that, everybody is proposing the same thing, direct access to the hardware. But you have to wait from a company that contacts another company. I don't know, maybe it was in the plan, maybe I'm making it up, maybe I'm just, but from outside point of view, it's very funny to see how all the announcements just come next to each other after they announce these things and start raising these things. By the way, most probably Vulkan is based on the work of AMD. Vulkan, Mantle, Vulkan. Mantle is the...
Where is NVIDIA in this position?
NVIDIA is just looking at it and following and saying, okay, they will do the stuff. I mean, they will say they will support most of the card. They are saying everything is ready. I mean, they're saying everything is ready. So they are working on it and they are ready to release. Intel also interesting. Intel was not very fond of, I mean, they were doing graphic cards also, but they were not, they say they are ready also for Vulkan, for example. And DirectX 12 also. Everybody is waiting, but everybody is ready for the real release of the stuff.
So can we expect some huge step forward for real-time ray tracing by this?
Not only real-time tracing, for everything. No, because real-time tracing is a little bit different. It was using real-time ray tracing. Okay, we can explain. I'm planning to explain that in another presentation how GPU really works and what is the basics between the GPU. But ray tracing is taking profit of the GPU through direct compute of OpenCL. The libraries that are not, you can use GPU. So most probably you will get some benefit because you won't have to go through it. But the SPI are more recent, so they are more designed to give you access, let's say.
Not very soon, but.
Can I say? As they are more recent API, they are more designed in a way for you to access to the hardware without all the crap that brings the API like Direct, like the previous version of Direct 3D and OpenGL. So you won't have so much gain, in fact. The major gain you will have from rendering from the old API. Okay. You will have benefit, but I don't know after how it is used. I mean, most probably, but. So that's where we are going now. Direct access to the hardware. But that comes with a cost. Direct access to the hardware means you have to be very, very, very careful about what you are doing, because if you try to access or to write to a memory in the GPU, while the GPU is rendering some stuff, then you have a crash. You crash your GPU. What will happen at this point? They say they will handle that maximum. So this is my conclusion. Because okay, all this stuff was nice, all this history stuff was nice, but if you want to start a new project now, what will you do? My advice for now. There is two cases. You are a beginner, or you are a beginner who want to learn, or you are starting a project. Maybe not with a lot of resources. You are not very proficient in multi-threading and multi-share, handling these kind of things. OpenGL 3.3. You can do a lot of stuff with that. You can already do a lot of stuff, a lot of nice stuff with that. No problem with it. You can try 4, but it brings a lot of complexity. This one is modern. In a way of modern GPU. You can do nice effects at very good performance if you are not targeting very exceptional graphics like that. You can do really cool stuff with it. So I will do that. Why not Direct 3D? It's a little bit out of scope, but let's say Direct 3D is not alone itself. It's not only coming with drivers in the operating system that come with it. You need maybe some additional library you need to install. We have this problem with ADeko, for example. Sometimes doesn't install quality. You have a bunch of things that goes on Direct 3D that makes it, unless you are using the very core of Direct 3D, you may have some problems. OpenGL, the nice thing, it comes with the drivers. Now, all the graphic cards support correctly OpenGL 3.2, which may be not the case for 4, because it's, maybe if it's old, it's more recent. So I would say go for it. Go for this one. It's modern, there is shaders, you can do stuff with it, go for that. If you are experienced, you can wait, because it is very important, you have to wait. Then I would say go for Vulkan, if you can. You are experienced, that means working with multi-processors doesn't frighten you. Concurrent access, multi-threading doesn't frighten you. You can wait, because I'm not expecting, even if everybody says they are ready for this kind of Vulkan or DirectX 3D12, I'm not expecting the first drivers to be released to be out of bugs. So let's say it's more for the scope of keeping 16 or something like that. Then I would say go for Vulkan, because you will have a huge, you will be more close to the hardware, and you will have most probably huge performance gain about that. And most probably you will be more close to what really happened in your computer. But otherwise, you are building a starting project and you just want to do nice stuff, go for that. That's all. If you have any question on this. It's not a technical stuff, so not good. Thank you.
Thank you.